All right, so today's class in Planet Earth, we're looking at topic 8, which is on fossils. So what is a fossil? So a fossil, it can be any trace or remains of once living organisms. So these fossils, they provide clues about when life began and also when plants and animals first lived on land. So we can study these fossils to learn when certain organisms flourished and then when did they disappear. Fossils can also tell us not only when and where organisms once lived, but also how they lived and behaved. So these fossils are useful in determining the history, the dates of the rock layers, and they may even reveal information about the environment and the climate. For example, Antarctica's climate was once very different than it is today because there has been fossils of leaves found there. This picture here, we're looking at amber. Amber is fossilized tree sap, and then sometimes it can preserve trapped insects, like in this example, we have mosquito. So genetic material has actually been successfully extracted from the insects that have been encased in amber. In this example here, this is a trilobite. Trilobite fossil. They lived in warm ocean water. They are now extinct. They existed about 200 to 400 million years ago. So types of fossils. Firstly, we'll look at petrified. What we mean by petrified, this is a rock-like substance that's formed when water penetrated dead organic matter and deposits dissolved mineral matter. So a carcass is in water, for example, and it'll sink down to the bottom, and then the body can then get buried by sediment. The soft parts, like skin, the muscle, the organs, those parts are going to decay very rapidly, and they're very rarely found as fossils. Then the hard parts, those include things like bones, the shells, the teeth. They may become altered to become fossilized remains. So when water penetrates the bones of a dead animal, that water will dissolve the calcium carbonate in the bones, and then another hard material like silica, quartz, that will deposit. So a deposit of another very hard mineral like silica and quartz remains, turning the bones into a petrified rock-like substance. Carbonaceous film. This is a type of fossil that is found in sedimentary rock when organic material is compressed and it leaves a thin carbon film. So for example, when an organism is buried under many layers of sediment, there's a lot of heat and pressure that may build up and it leaves.
I can't.
All right, so when that organism is buried under many layers of sediment, there's a lot of heat and pressure that can build up, and it leaves a thin film of carbon residue on rock surfaces. And then that residue can form an outline of the organism. So that's what a carbonaceous film is. And then we may have original remains. This is the actual organism or part of it may be preserved as a fossil. So animals and plants have been found preserved in peat bogs, tar pits, and amber. Woolly mammoths have also been found in the Yukon, preserved in the ice. We can also have trace fossils. These are just evidence of an animal activity. So trace fossils include like wormholes, burrows, and footprints. Those can be fossilized, but those are called trace fossils. So for example, we have some examples of different kinds of fossils here. This is a reconstructed model of a dinosaur egg. This was found in Alberta. Here we have fossilized dinosaur tracks, which have been found in Alberta, actually over 20 sets. So we can see fossilized dinosaur tracks. These would be trace fossils of footprints. So again, trace fossils, they're evidence of the animal activity. Here, the Morella most abundant of the Burgess Shale fossil animals, could be a distant relative of crustaceans. Here we have a fossilized patch of dinosaur skin found in southern Alberta. It shows a pattern of skin, but not the color, like the color is not preserved, but we can see the pattern of the skin. Here, again, like we saw before, trapped in resin, which turned to amber. So we have an insect here. This is a coiled ammonite, common fossils found in Alberta. Sometimes hundreds of them are found clustered together. Next, we're going to talk about fossil mold and cast formation. So a mold, this is a type of fossil in which the hard parts of the organism, they have dissolved. It leaves behind a cavity in the rock. So sometimes an organism will fall into soft sediment like mud, and as more sediment falls, the original sediment will gradually turn into rock. Then water and air will pass through the pores in the rock, reaching the organism. The hard parts dissolve, and it leaves a cavity in the rock called a mold. And then a cast is a type of fossil in which sediments or minerals have filled a mold and hardened into rock. So here in figure A, an ancient animal has died, its remains sink into the mud, the soft parts decay very rapidly. In figure B, the animal's hard parts are buried by sediment. Millions of years pass, and the sediment will slowly turn to rock. Next, in figure C, the skeleton gradually dissolves, and it leaves a mold in the rock. And then other sediments can fill the mold, and that forms a cast. Next here, the surface rock is eroded, and the fossil is exposed. All right, often when fossil remains are found, they are only broken fragments. So reconstructing these fragments into a full-sized animal takes a lot of skill and inferences based on a knowledge of modern animal anatomy. So creating a lifelike illustration from these fossilized bones, it requires a careful study of the bones, a knowledge of anatomy, as well as imagination. So imagination is needed where we don't have the evidence, such as the color of the skin. So here we have Allosaurus. This is the Allosaurus skeleton before reconstruction. Reconstructing fossil bones into a full-size skeleton is like putting together a three-dimensional puzzle without the picture on the box. This is what it looks like after reconstruction. So again, a team of experts and scientists with a wide range of knowledge. The scientists will compare the new bones they find to known dinosaur skeletons and to skeletons of modern creatures. And then this is a completed Allosaurus after the skeleton has been reconstructed. The next step is to put the muscles on the bones. The arrangement of the different muscles is established by examining, for example, scars on the bone where the muscles were once attached. Next, we would have to add on the skin. Fossilized skin impressions that have been found suggest that the dinosaur skin was scaly, quite similar to a reptile skin. Here we're looking at geological columns. So rock formations, they are deposited in layers from the oldest being on the bottom, youngest at the top. So paleontologists can use these layers or these geological columns to help determine the age of the fossils they find. So for example, fossils that are found in layer 7 here will be older than those found in layers like 1 to 6. Right, so I'm going to pause here